Hi everyone, new recording, new review of grade 7 entitled Transformations and Symmetry. So normally we should know the difference between and distinguish between different transformations, okay, like when sliding, when flipping and turning plane shapes. For example, translation is to slide a shape, reflection is to flip a shape, and for sure about a line, a specific line. Turning a shape to turn a shape around with respect to a center of rotation. So these processes are called geometrical transformations. So normally we should know that we have an image, congruent image from of the original shape when sliding, flipping, and turning a shape. So what about translation? Translation by definition is a sliding movement. When a shape is translated, every point in the shape, it moves in the same distance. So normally we move in the same distance to obtain the image one, green one from the purple one. Okay, in the same direction, same distance, same movement. And to slide the shape, we make an identical copy. As we said before, the image is an identical copy of the original shape, and that translate and then translate it as needed. Okay, so due to translation, we should know that the properties of translation is the matching sides of an image and its original are the same length. Normally, we have an identical with all the dimensions. Okay, all the sides of the copy, the image, are of the same length of its corresponding in the original. The matching angles of an image and its original are at the same side. Also, all the we have a copy of the same angles from the original, and the areas are respected and conserved. Okay, we save the same. We have the same areas also of the image. The image and the original have the same area. So we should know that horizontal translation results in image with the same y coordinate, and vertical translation results in image with the same x coordinate. If we are dealing and, for example, drawing an image in a plane, okay? So this is the translation. What about the rotation? Rotation, we need a center of rotation. So we should fix a center of rotation. For example, A could be a center of rotation from the original, and could be from any point in the plane. Any point A, or the center of rotation could be any plane in any center, any point in the plane. Okay, so a rotation is a turn around a fixed point called the center of rotation, and the direction of rotation can be clockwise and or anti-clockwise. Clockwise with the same way of the direction of the clock, and the anti-clockwise the opposite one. When a shape is rotated, we know that every point on it's moved through the same angle. So the same angle. So we use the compasses, we use a semicircle to compute and to identify the angles that we should rotate about. The distance from the center of rotation to any point on the shape stayed the same. We should note also that we have to do some raise and raise the we should, for example, like in the translation, we can only take the very strong point, or the critical point here are these corners, or this point, the vertices of this square are the critical point that make our shape. Also, we can say here that the vertices of this parallelogram make the shape. So normally it is sufficient to rotate these 4 or 5 vertices to obtain the image. So we draw rays from the center of rotation from anywhere, fixed center of rotation to each one of the vertex to keep the same distance, and to turn the ray about the angle that we want. So in the clockwise or anti-clockwise direction, Then we have our new and the copy of this vertex. About the reflection, we need to have and to flip the shape of a fixed line. This fixed line called the line of reflection. So also the line of reflection could be one of the sides of our shape, or it can be any line in the shape in the plane. The line joining each point and its image make a right angle 90% with the line of reflection, and we should know that every point and its image are the same distance from the line of reflection. So to return to its original position, another reflection is required. So if we do the reflection 2 times in a way or a consecutive way, we'll obtain the previous and the original one. Sometimes, in some cases, we should note that each of these transformations can produce the same result as the others. Okay, like we draw it here in this with this chart. What we mean by line symmetry? The line symmetry is the line about it. If we fold a shape about it or on it, we fold it, so we obtain an identical copies of the other side. So for example, the shape can be divided into 2 halves that are the exact reflection of each other. So we should know that this line of division, this line where we fold it into halves, the line is called the reflection. This is known as reflection line. Okay, for example, this A, if we fold it here, so we will obtain 2 identical halves, this one and this one. But if we take this one, if we fold it, no, we don't have matching. If we fold it, the right side down doesn't match the left side, and so on. Here, for example, we don't have any axis of symmetry. In the following exercises, we want to state whether the original blue figure has been translated or rotated or reflected to its new position in the red one, the copy one. For example, here we have a reflection, rotation, translation, and so on. So, for example, a reflection, and so on. Normally, translation, we can translate it to the right and to down. How to plot? We have a triangle. We want to plot it according to this statement, translated 2 units right and 1 unit down. For example, we have this right, the blue one, and we want to translate it 2 units right. So we have 3 vertices. It is sufficient to translate these 3 vertices 2 units right and 1 down. For example, 2 units, 1 down, so to obtain its image. 2 units to the left, to the right, 1 down. And 2 units, 1 down, we obtain A prime, B prime, C prime, and we can also join these new vertices to obtain the images, the new image or the copy of this one, with a translation of 2 units right and 1 unit down. What about rotation of the same triangle? About C through 1/4 of a turn. 1/4 of a turn, so we need to know 1/4. It is a 1/4 of 30, the turn, the complete turn at 360 degree. It is like a circle, whole circle. 360 over 4, it is normally it is 90 degree. So normally we want to rotate A 90 degree. So we use the compasses about A. So normally about C. We have a C, we put the compasses here and we turn to do a circle, to have only to guarantee that the same distances, and from here we count 90 degree to the right clockwise. So clockwise in this direction. So 90 degree to obtain A. Okay. Then for B, the same, CB, then we draw a circle or partial circle, okay, and we count 90 degree, and we have also the same distance from C to obtain B prime, and the same for A for C, because C is one vertex of the original triangle. So, and it is in the same time the center of rotation. So normally we its image is congruent with the same. So normally we join A prime, C prime, B prime to obtain our new triangle. What about reflection? When the reflected line is CB. CB, so normally if we reflect C, okay, with respect to C, so we'll obtain C prime as C. And the same for B prime because CB is our line of reflection. What about A? So A, we reflected, we do a perpendicular and the same distance from this line from here to here and from there to obtain A prime. So A prime and we join finally, eventually, we'll obtain A prime, C prime, B prime as a copy of the original triangle. And I will keep, you can keep and you can have the remaining exercises as a self-assessment. About what we need to know about the axis of symmetry, it is very easy to know because we have an isosceles triangle here. So we have only one axis of symmetry. If you fold it, the right side of this triangle matches the left side. If we take, for example, this one, no, we don't have more than one axis of symmetry. With an equilateral triangle, we have three axes. We have three axes. And also, if they ask us to complete the following shape given the axis of symmetry, we have the axis of symmetry. So it is the same way as having a reflection. Having reflection with respect to this line as a line of reflection. So normally we have this vertex, and this one, and this one. This one and this one are like in the line of reflection, so their image are the same. This one we draw a perpendicular line to the right, and we count the same steps after the reflection point to obtain the same distance. And this one is here, so we draw it and we obtain its image, or it is a reflection. Thank you for listening. These are the important information about this recall, and we will meet in the next video. Bye bye.